Topic for today is analysis of pin-jointed frames and method of members. So previously we had method of joints, sections, and then the last analysis of structure is method of members. So introduction. Before we start doing method of members, let's start with a few definition of terms. First is what we call your three-force members. So three-force members are the following. They are subjected to three or more forces applied at different positions. And then the next, it is subjected to bending loads. And then lastly, it is a non-axial member that is not simply in tension or compression. Now, in our previous topics, we were considering two force members, right? Meaning the forces are at the ends of your member, hence two force members. Now, three force, okay, we have forces at different positions. That means it's not just at the end, it could be at the actual member itself or along the span. Now, because of this, right, those types of loads, or we now have bending loads present, okay, forces that are not along the axis of your member. Hence, three-force members are not axial, they are non-axial members, okay? So in contrast to our previous lecture, where the forces involved were either in tension or compression, for three-force members, it's a different kind of analysis. Okay, so previously we talked about trusses. Now we have frames. So frames are pin-connected structures with some of or all members are three-force members, okay? So not necessarily all members need to be three-force member for it to be a frame. It could just be one member. Later on, I'll show you examples of that. Now, to reiterate, okay, for three-force members, again, forces are not directed along the axis of that member. Okay, it could be directed along the span. Because of that, if you try to pass a plane through a three-force member, it shows that the member is subjected to bending, right? Bending along with axial stress or axial forces. Therefore, because of this, it's not convenient to analyze a structure by method of joints or sections. Because again, for joints and sections, our forces or our members are only in tension or compression. Now we have bending, so it's not that convenient to use those methods. So now we're going to introduce our third method, which is method of members. So it's the method where a three-force member is disconnected from the structure and a free body diagram of the member is drawn. So to compare, once again, method of joints, you isolate a joint and use your three equilibrium equations. Method of section, you use a cutting plane, cutting through no more than three members, okay, and then you're going to isolate one side of your structure. And here in method of members, you're going to isolate the actual member itself. Okay, so those are your different methods for analysis of structure. Now, these are the principles for method of members. So first, when separating members for analysis, forces and their components exerted by the connecting pin must be consistently represented as acting opposite direction on the separated members. Okay, so in your previous examples, previous lessons, right, we had consistency of direction for forces. Or method of joints and section, if we assumed a force to be compression, okay, if that force is used again on another joint, it should be again drawn in compression. Okay, so that's your uniformity or direction. For method of members, now it's the opposite. For example, in one member, a force is directed to the left. On the connecting member, that force now should be to the right. And then lastly, if direction assumed is incorrect, the solution will give its correct magnitude, but with a negative sign. So it's the same with our previous solutions, wherein we assume direction, we get a negative answer. That means our assumption of direction is incorrect. However, the magnitude is correct. Okay. So to explain, let's have this frame. Okay, so you have frame A, B, C, D. Here on frame BC, we have a point load along its span. Okay, because of this point load, member BC is a 3/4 member. Okay, so let's try to isolate that. Isolating member BC, you have this. Now, again, this is non-actual. 3/4 members are non-actual. That means, okay, this is incorrect. Okay, that's not how you draw the forces acting on the member. Instead, okay, the reactions at these supports, okay, so these are hinges. The members of a frame are connected via hinge, right? So the reactions at a hinge could be at an angle, okay? Could be this way, right? And then to simplify that, what we'll do is for 3/4 members, the reactions at each hinge is just vertical and horizontal. And similar to your previous analysis, you're guessing the direction, okay? So we have an upward reaction here. Let's call that BV for vertical, and then this is BH. Now, similar to that, okay, we have another hinge here, so there's reactions there again. We're gonna guess direction, so I'll call this CV for vertical reaction at C, and then CH. Okay, so that's the free body diagram of a 3/4 member. There's a reaction at every hinge. Now let's count how many unknowns we have. We have 1, 2, 3, 4. We have 4 unknowns. Can anybody tell me how many equilibrium equations we have? Very good, Francisco and Colin Legado. So we have 3. Okay. Summation of forces, horizontal 0, vertical 0, and moment 0. So we only have 3 equations that we can use. 3 equations for unknowns. Therefore, and, okay, for unknowns, 3 equilibrium equations are not sufficient, okay, or are insufficient, right? So meaning we cannot solve this member alone, okay? We need to use the other members, either BA or CD, to solve for the unknown. Okay, so that's usually the process for method of members. You're gonna isolate one, you're gonna see that you don't have enough equations to solve for it, then you're gonna move on to a connecting member. So let's use this connecting member AB. Okay. So connecting member AB, then there's a pin here. Our reactions are the same for a pin, right? It's always vertical, or rather perpendicular and parallel to the surface. Okay. So let's call this reaction at A. So AV, since vertical. Again, this is a pin reaction. So there's always perpendicular and parallel reactions. So now I'll call this AH. Then, okay, this is at reaction at support A. Then we have hinge at B. Okay, hinge at B. Now what will I do here? There's a hinge there, therefore there's going to be a reaction. Now remember the principles said in the previous slide, right? Consistently represented as acting opposite direction on the separate members. So that means looking at our previous drawing, right? Here at hinge B, this is also hinge B, right? They're connecting members. So you're gonna draw the opposite force. So here initially I have BV as upward. On the connecting member, you should draw the opposite, meaning BV is now downward. Okay? Similarly, BH to the right, draw the opposite, BH now to the left. Now it doesn't matter if it's towards the point or not. Again, this is not compression tension. So you can draw it that way or this way, BH. Okay, it doesn't matter. The direction is what matters. All right, so again, opposite. So that's how you draw free body diagrams for method of members. Okay. Any questions so far? Before we move on to examples, please answer in the chat. Okay, great. So no questions. Let's try to have a few examples now. Okay. Example number 1. The structure shown in the figure is pinned together at points A, B, and C and held in equilibrium by cable CD. So pins at A, B, and C, pins or hinges, they're the same, and then held in equilibrium by this cable CD. A load of 12,000 pounds is acting at the midpoint of member AB. Okay, so here you have this. Therefore, member AB is a 3/4 member. So I can't use method of joints or sections on that member. Okay? And the load of 8,000 pounds is applied at point C. So it's applied at the joint. Okay, it's not creating bending. Determine the reaction at A, internal force in member BC, and tension in cable CD. So we're looking for 3 things: reaction at A, tension at cable CD, and then internal force in member BC. Okay, so let's do that. Let's start analyzing this question. Okay, let's start first with reaction at A. As you can see, this is a pin, right? Or hinge. Therefore, we have 2 reactions or possible reactions. One parallel and one perpendicular to the surface. So perpendicular to the surface, right? This is the surface. We're guessing direction. I'm gonna guess it's to the right. And then let's call that AV, AH, since horizontal. Then I'm gonna assume this is upward. And then let's call that AV. Okay, so let's start. So we're looking for reactions, right? Usually, to solve for a reaction at a support, you're gonna use moment on the other support, which is this right here, okay? So now, I'm gonna do moment about point D, okay? So your first equilibrium equation equals 0, right? Let's start with 8,000, okay? So moment, rotate about D, that's clockwise, therefore positive 8,000. Then we need the perpendicular distance, which is this length. Now we have a problem. We don't know that length. All we know is 1644, right? Again, we don't know this length. So we need to solve for that first. Okay, so let's try. So this is what we need. This length. Choose a variable for it. Let's try using variable x. So this is what we need. Okay, so I need to multiply this by x. So to solve for that, look at the drawing and analyze. Now this is x. And this length is also x, right? And if I isolate that, we actually have a right triangle. So this is A, A. We have a point B here. Okay, so this is our member. And A, B, C. And this is what we need. This is your length x. Right? A to B, the length is 8. Okay. And then we have an angle 30 here. 8. This is angle 30. And we have another given 16. If you've noticed, right? 16 is the hypotenuse of your right triangle, then we have an angle here. So we can use trig equations to solve. So I'm going to use cosine since this is the length that I need. So cosine 30 equals adjacent over hypotenuse. Adjacent to 30 is this length x, which is what we need. Then hypotenuse is 16. Then solving for x, we'll get 13.86. Okay, by the way, for the first problem, I'll just solve it on my own. You just have to listen and understand what's going on. Okay, so 13.86. Store that in our calculator for easy retrieval. Okay, so now that is our value for x, right? We're just going to use that here. Next, move on to the next force. We have 12,000. Rotate about the, again, that's clockwise, so positive 12,000. Perpendicular distance, let's see. It's this length, which is equal to 4. And then lastly, next we have AV, which actually passes through D. So I'm going to ignore that. And then lastly, we have AH, rotate about D. That's counterclockwise, so negative AH. And then perpendicular distance is this length. And once again, we don't know that. So we need to solve. Let's try solving. Okay. Let's name this total length as y. Okay. So we need AH times y. So let's solve for y. Now, there's a number of ways to solve for this. Okay. One way is to draw a straight line here. And notice we have two right triangles. And then we have certain given angles and lengths. And then from that, we can solve for the total length, y. Okay? So if I can solve for this height, which is, let's call it a, and then this height, which is b, I can solve for y. It's just a summation of a and b. Okay? So let's start with solving this first. Once again, let's try drawing that. Right? So we have d and c here, and this is your a, which is what we need. This angle is 53. And this, right, this leg is actually x. And we know x. Right? So since we know x, we can use again trigo equation, specifically tangent. So tangent theta equals opposite over adjacent. Opposite is x. Adjacent is a. X is 13.86. Theta is 53. Okay, so from this, we can solve for a, which is 10.44. And again, ideally, store that value. Then finally, to solve for b, again, consider another right triangle. Okay, so we have this. Yeah. Okay, this is 16. This is what we need, b. Okay, and then look here. This is a right angle. This angle is 30. Therefore, I can solve for this. 90 minus 30, that's 60. So this is 60. And again, using trigo equation, I can solve for b, specifically sine. So sine theta, sine 60. Half, not sine 60, cosine. Cosine 60 equals adjacent, which is b, over hypotenuse, which is 16. Therefore, b is just 16 cosine 60. That is 8. Okay, so 8. So no need to store. That's the whole number. So take note of your units, okay? All of them are in feet and then pounds. So therefore, solve for y. That's just a plus b. Therefore, you get 18.44. Now, another way to solve for this, okay, this is just one way. Another way is to use sine law. So sine law, we're now going to consider this total triangle. Okay, again, the goal is to get y. And then you have this length here, 16. You have 53. And you already know, 16 and 53. We know that this is 60. You can use sine law, right? Okay. Knowing that this is 60, 180 minus 53 minus 60, you can get this angle, sine that angle over y equals sine 53 over 16. So you can try that, okay? If you want to practice, try using sine law to solve for these variables. Okay? Or use sine law. So now we have y, which is 18.44. Just sub that here to solve, right? There's no other forces. So equate that to 0. Then from this, we can solve for AH, which is 8,613.77 pounds. Okay. Now we're not done. We need reaction at A, not component of reactions at A. So next step is to solve for AV. Now to solve for AV, typically you'd use summation of forces vertical, right? Now if we try to do that, okay, let's not forget the support. There's a reaction there. And since the force for this support is a cable, the reaction there is actually just this. Okay? It's the same direction as your cable. And we can call that T. Okay? Now because of that, okay, so this is T. This T has also a vertical component. So let's do, this is your TV. And then we also have TH. Okay, so if you do summation of forces vertical, you have two unknowns, AV and TV. So I can't do that yet. So instead, let's use the other equilibrium equation, which is summation of forces horizontal. Okay? And you'll notice the only horizontal forces are AH and TH. Okay? So AH to the right, positive. Now how do we get TH? So to get TH, I need to know this angle here, right? And that angle is actually equal to, or this, to get that, okay, just know that you have 53 here. Okay, let's make that larger so that you can see. See here. So this is our force, right? So all we know, this is 53, right? Vertical angle, if that's 53, this is also 53. Therefore, this angle is 90 minus 53, which is 37. Okay? Therefore, this angle is 37. Okay, so I'll place that there. So again, this is 37 degrees. Okay? So therefore, the horizontal component is T cosine 37. So it's horizontal. To the left, right? To the left, therefore negative. So negative T cosine 37, equate that to 0. I already know AH is this, sub that here. I can solve for T. Solving for T, we should get 10,785.61. Don't forget the unit pounds. And that's actually one of our being asked variables in the question, right? Tension on cable CD. And it's this. We solve for that. This value reaction of T here is the same as the tension in this cable. Okay? So that's our first answer. Next, now that I know T, we can use summation of forces vertical to solve for AV. So vertical, let's start. AB is upward, so positive. T is also upward. To get the vertical component, that's T sine 37. So plus T sine 37. And again, we already know what T is. And then downward, so negative 12,000. Also downward, negative 8,000. There's no other forces, so equate that to 0. And then from this, we can solve for AV. And AV now is 13,509.06. Okay, now we have AH and AV. We can finally solve for RA. So RA is just AH squared plus AV squared. And then final answer, 16,021.60. Okay, so that's the magnitude. Next, we have to solve for direction. So your theta. Theta is arc tangent AV over AH, right? So AV over AH, you should get 57.48. And by the way, all our answers are positive, therefore correct assumption for direction. So our assumption is to the right and upward, therefore, you can just draw the arrow to the right and upward. So now we have two answers, your tension and reaction at A. Now finally, what we need is force in member BC. We need this. Okay, how do we do that? Well, first of all, analyze is this a 2-force or 3-force member? Now looking here, there's no force along its span. Okay, therefore this is not experiencing bending. So it's a 2-force member, meaning I can use method of joints or section that uses this member. Okay. Now if we use method of joints, right, you would typically solve for this and here. Now you can't do that because member AB is a 3-force member, meaning its internal force is not in tension or compression only. So we can't do that. I can't do method of joints. What we can do now is method of sections. Now, as long as you're following the rules for method of sections, you should be able to use it. Now try. We'll use a cutting plane along this area, right? And then I'm gonna isolate the bottom section, right? I've only cut through AC, which is also a 2-force member, and BC, which is also a 2-force member. And it's not more than 3 members, so therefore I can use that method. Okay. So method of section, right? I'm gonna just copy this. Okay. Now that you have this section, remember wherever you cut your member, that is where your forces will show up. So meaning here, okay, there's gonna be a reaction here. That is member AC. You can assume tension or compression. If you've watched our videos, I always like to assume tension in method of sections. That's because that's just convenient for me. So F AC, and then this is what we need. This force, which is F FBC. Okay, so FBC. So to solve for this, okay, you're gonna use moment on one of the supports or one of the joints. Okay, so the point where we'll use our moment should be here at A, because FAC passes through A, so that I don't have to deal with FAC. Okay, so summation of moment at A. AH, AB, FAC all pass through A, so ignoring that, we have 12,000 rotate about A. That's clockwise, so positive 12,000. Perpendicular distance is 4 feet, so times 4. Next, FBC. Perpendicular distance of FBC from A is this length right here. I don't want to solve for that, so let's use Varanon's theorem, which is just using the components, right? The horizontal component passes through A, so I'm going to ignore that. So what I need is a vertical component of FBC. Now, to get the vertical component, I either need the angle or its slope. There's no slope given, okay, although you can solve for it if you want to. Okay. I just need this base and height to get the slope of BC, or you can solve for the angle. Okay, the angle that we need to get its vertical component is this angle right here. Okay, so let's call that beta. So I need to solve for angle beta, which is also this. Okay, so how do we do that? Now take a look at what you know. Okay, so I know this total length x, right? That's 13.86. This is 8. If I get, or if I subtract one from the other, I can get this base. And then you'll see that you have another right triangle. Okay. Also, the height of your right triangle is b. So I know the base and the height. I can use the trigonometric function tangent to solve for beta. So let's do that. Okay. I'm gonna draw here. Okay. Again, this is your beta. This length, okay, again, this is the right triangle that I'm drawing. This is x minus 8, right? And then this height is actually b. Okay, so b. Using our equation, tangent beta equals opposite, which is b, over adjacent, which is x minus 8. And then from this, you can solve beta is 53.79. Okay, and then store that because we need it. Okay. Now, there's another way to solve for this, and that includes cosine law. So instead of considering this right triangle, you can consider this triangle instead. Use cosine law, right, to solve for this angle, or use cosine law to solve for this length, and then sine law to solve for this angle. Okay? Again, if you want to practice, try doing that. So again, now we have your angle, vertical component, that's FBC sine theta. Okay, so rotate the vertical component about A, that's counterclockwise. So negative FBC sine theta, right? There's no other force. Perpendicular distance. This is the perpendicular distance, which is equal to 8 times 8. There's no other force, so equate that to 0. And then from this, we can finally solve for FBC, which is 7,435.88. Our answer is positive. Therefore, correct assumption, it is in tension. So tension. That is our final answers. Okay. So that's number one. Any questions for number one? Please answer in the chat. How about the others? Please answer as well. Any questions for number one? Okay, great. Now let's go to number two. And now I'm taking recitation for number two. The frame shown in the figure is supported by a hinge at A and a roller at E. So A and E. Okay, paano nalaman na tension? Going back. We know it's tension because we assumed our force FBC's tension. Remember, whenever your force is away from the joint or away from the section, that's tension. Towards the joint, towards the member or section, that's compression. Okay, you're gonna assume those two things. For method of section, I always like to assume tension. Again, that's just me. You can assume compression always, up to you. Okay, I assume tension here, then I created my equation. The answer is positive, therefore correct assumption. It is in fact tension. If the answer here is negative, that means I have an incorrect assumption. It's gonna be compression, but the magnitude is the same. Okay. Okay, again, going back to number two. Compute the horizontal and vertical components of the hinged forces at B and C as they act upon member AC. Okay, so this term is important. Upon member AC. That means that is the member that you need to isolate and then solve these hinge forces for. Okay. Again, what are we looking for? Hinge force at B and C. So here and here. Right. On member AC. Again, that is what we'll isolate. We have this. We isolate AC. We have something that looks like that. Okay. This is A, right? And then this is C. And then we also have a point B here. Okay. Next step, you're gonna assume direction of your forces. Again, there's always vertical and horizontal force on each hinge. So let's start with A. So A is actually a support. It's a hinge, so the reactions there are perpendicular and parallel. Okay, so again, you're gonna guess direction. I'm gonna guess this is upward. Okay, it's the same thing here. This is also upward. Okay, so that's AV. And assume direction for horizontal. I'm gonna assume it's to the left. And then this is your H. So H. AV. H. Do the same thing for the other forces. Here at B, I'm gonna assume downward. So this is BV. And then this is to the right. BH. And then same thing. Let's say CV is downward. And then to the right, to the left. CH. Okay. Now, what we need are these BV, BH, CV, CH. Okay. And then the directions that will follow are the ones for member AC. Because if we remember here, right, depending on which member you choose, the directions are different. If I choose member BC, my BV is upward. If I use member AB, my BV is downward. Okay, so that's why this term upon member AC is important, because that will determine which member are you focusing on for your answer. Okay, and in this case, it's member AC. Okay, now so let's solve. It's a lot of unknowns, 6 unknowns. I need to reduce that number. So try to look for what you can solve for first. Now, usually what you can solve for is reactions at supports, which means I can solve for A first. Whenever we solve for reaction, then you're taking moment on the other reaction or on the other support. So that's E. So let's start summation of moment at E equals 0. Okay, AH passes through E, so ignoring that. AV, that's clockwise, therefore positive. Perpendicular distance, that's 1, 3 plus 1, that's 5. Let's look for another force. We have this 24. Rotate about E, that's also clockwise, so positive 24. Perpendicular distance. Can anybody give me the perpendicular distance? Correct, Lauren and Ricky. It's 0.5. Chua, okay. 0.5, how? This entire length is 1.5, okay? Distance of D from E is 1 meter. Therefore, what's left is 1.5 minus 1. This is 0.5, okay? That's why distance is 0.5. There's no other force, right? So equate to 0. From this, please solve what is AB. Remember, sign is important. Okay, correct Rain and Eman. Rain and Lauren. Nauna si Lauren. So, Stochero and Chua. Chua. It's negative 2.4. What does the negative mean? That means I have an incorrect assumption for direction. Okay. So AB is actually downward. Now, again, you can do one of two things. You can correct your mistake, meaning you can just delete this, make it downward. So therefore, this is negative, and now this is positive. Okay. Or if you don't want to go back and correct every mistake you make, if you have a lot of incorrect assumptions for direction, you can just keep it, right? And just take note. If you're gonna use this, you're gonna include the negative sign in your solution. Okay. So therefore, it's 2.4. It's actually the move. Okay. Now I have AB. That's actually not what we're looking for. I'm just reducing the unknowns here. Next, AH. Now, this is a roller, right? Meaning there's only perpendicular reaction there. That means we only have EV here. There's no horizontal reaction, meaning there's no horizontal force nor reaction here, so AH is actually 0. Okay? Right, so now I have AV and AH. I'm down to 4 unknowns, which is what we need. So how do I solve for that? Now, 4 unknowns, right? We only have 3 equilibrium equations. That means that's not enough to completely solve for this. Ah, why are forces BV and CV not taken into account in getting the moment about E? That is because this equation is considering the entire structure. Okay. So again, summation of moment at E is considering the entire structure, not this free body diagram. Okay. So this entire structure does not include the internal forces or reactions. For analyzing for analyzing total structures, you're only going to consider support reactions, and external forces. Okay. Again, this is not what we used in this equation. We use this entire structure. Whenever you're solving for reactions, most of the time you're considering the entire structure, not a free body diagram. Right? Okay. So once again, these are solved for done. I need to solve for this. There's not enough equilibrium equations, right? So what do we do? So if you remember for method of members, okay, because there's not enough equations, you're going to analyze connecting member, right? So that means you can either analyze CE or BD. Those are your connecting members. If you analyze CE, you have the same thing, right? You have a lot of unknowns there. So that's not advisable. So instead, try isolating BD and then solve for B so that you have these reactions. Okay, let's do that. Member BD. Okay, so let's draw the entire member. Don't forget the external reactions. So we have these two. There are two hinges, right? And then we have an external force here, 24 kilonewton. Don't forget the external forces. Okay. Now, remember, when you have two connecting members, whatever you assumed on the first member you isolated, the forces are the opposite. So this is to the right, therefore I'm going to assume this is to the left. This is your BH. This is downward, so I'm going to assume this is upward. And this is my BV. Okay? Next. So D, you can just guess again. I'm going to guess it's to the right. Yeah, to the right. This is DH, and then downward DV. Now you'll see you don't actually need to, because to solve for BH or BV, I'm just going to use an equilibrium equation, which is moment. And I'm going to take that about D so that DH and DV cancels out. Okay, so as you can see, I don't need DH and DV. So summation of moment at D equals 0. BH passes through D, so ignoring that. Next, BV, rotate clockwise, therefore positive BV. And then what's the distance? This is 3 meters. This is 1.5. So this is 3. This is 1.5. Perpendicular distance of BV from point B. Let's write that. Let's write those. So BD. Now that's 3. So BV times 3. What else? 24 kilonewton. Okay. So rotate 24 about D. Again, that's clockwise. So positive 24. Perpendicular distance 1.5. There's no other force equate to 0. From this, please solve BD. Correct, it's negative 12. Very good. Correct, Rain and Colin. 2 points ka na, I think. So who's the next one? Chero. 2 points ka na. So the next person is Rafaela. Pangalan. Okay. Negative 12. Okay. So it doesn't matter. You can just keep that negative 12 when you go here, okay? So negative 12. Now I have VB. Okay. So now I know this. Now I'm left with 3 unknowns. Therefore, now I can focus here and use my equilibrium equations to solve for our forces. Okay, so let's begin. I already know BV. To solve for BH, I'll use an equilibrium equation. Specifically, I'm going to take moment about C, so that CHCV cancels out. The only unknown now is BH. Okay, so summation of moment at C equals 0. Now we're considering this free body diagram. So let's begin. AV, rotate about C, clockwise, therefore positive. Now what about its distance from C? Can anybody tell me? Perpendicular distance of AV from C. Nope. Very good, Michelle. It's 2.5. How? This is AB, right? That's the same thing here. And this is C. This is the length that I need. Now, considering this is symmetrical, if I draw a straight line here, that just divides your 3 meters into 2 equal parts. So this is 1.5, right? So 1 plus 1.5, that's 2.5. Okay? Yeah. Now let's specify. This is 2.5. So AV times 2.5. Next, AH, rotate. Again, that's clockwise. So positive AH. And AH is 0, so I can ignore that. Okay, ignoring AH since it's 0. Next, what else? BV. BV rotate about C. That's counterclockwise. So negative BV. What's the perpendicular distance of BV from C? Very good, Michelle and Marilyn. It's 1.5. No, seriously. 1.5, why? Again, this is your B, that's where your BV is, right? This is the perpendicular distance from C. Again, that just divides your 3 meters into 2, so this is 1.5. Okay? So BV times 1.5. What else? BH. BH is counterclockwise, so negative BH. And its distance is easy to see because as you can see, that's just 3 meters, right? Again, 3 meters. There's no other force since CH and CV pass through C, so you equate to 0. Next, I'm gonna write down the negative sign so that you can see how you should solve. So let's look at AV. AV is negative 2.4. So negative 2.4. Again, since I didn't change directions, you're gonna keep the negative sign. So negative 2.4 times 2.5. The negative, what's BV? BV is negative 12. So include the sign negative 12 times 1.5 minus BH times 3 equate to 0. Now from this, please solve what's BH. Make sure to tell me, is it positive or negative? Okay, very good. It's positive 4. Okay. So correct, Naomi and Gian. And you also. It's positive 4. So that means correct assumption for direction for BH. On members AC, it is indeed to the right. So 4 kilonewton to the right. So that's one of our answers. Okay? And then next is to solve for CH and CV. To solve for those, you're going to use the remaining equilibrium equation. We already use moment. The rest are summation of forces vertical and horizontal, right? Let's start with vertical. Summation of forces vertical equals 0. So positive AV, negative BV, negative CV equals 0. Again, include your negative signs if there is. AV is negative 2.4 minus BV is negative 12. Please solve what's CV. Correct, Matthew and Lauren and Jomar. So Matthew, Anilon, correct. You are your 2 points already. And so the next person. U. It's positive 9.6. Okay, positive, because you're gonna transpose that here, then this is positive 9.6 kilonewton. Therefore, correct assumption, it is indeed downward. Okay, and that's your second answer. And then, lastly, summation of forces horizontal. So negative AH, again, that's just 0. Positive BH, negative CH. That's just 0. So what's BH? 4. So CH is 4. Yes. Positive, therefore correct assumption, it is to the left. Okay, and now finalize your answer. What are we looking for again? Components at B and C. So let's start with B, BV. So BV is 12. Now how do I decide its direction? This is negative. Therefore, this is also negative, meaning this is an incorrect assumption. Right? BV is not downward. It's actually upward. Okay? Again, the directions are based on what's said on the problem, which is AC. Okay? This is an incorrect assumption since I got a negative answer. So therefore, the correct one is upward, the opposite. Okay? And then BH, 4 kilonewton to the right. Next, CV, 9.6 kilonewton downward. And then finally, CH, 4 kilonewton to the left. That or those are our final answers. Okay? Any questions for number 2? Please answer in the chat. Hindi po ba mababago yung sign kahit wrong assumption? What do you mean? When you're drawing your free body diagrams, whichever you start with, okay, that is where you're gonna base everything else. I started here, okay, and then I drew the opposite here. So even though I got a negative here, I'm still gonna follow this, okay? Again, you have two choices. You can just keep all of your drawings as is. You're not gonna change anything. Just remember to follow the correct order of your free body diagram, meaning, again, I started here, so the next one should be the opposite. You can start here, and then if you draw this, it should be the opposite of that, okay? So you can do that. Just remember, again, to include the negative sign since you didn't change the sign. Now, another way is to change the sign, to change your direction. So for example, here, negative 12, therefore I know that's not upward, this should be downward, right? And then the opposite of that is upward. So here, this should be upward. Okay. Now, when I do my equation, right, this is now gonna be clockwise. So this is positive. This was positive. And since I changed the sign, this should also be positive. Okay. So it's up to you which is easier. If you're just gonna keep the negative sign or if you're gonna fix your directions along the way. But again, just the important thing is drawing the correct free body diagram. Okay? Any other questions? Right. If you don't have questions, let's move on to number 3. The frame shown in the figure is hinged to rigid supports at A and E. Find the components of the hinge forces A and E and the forces in member BC and BD. We're looking for 4 things. Components of hinge forces at A and E. That's A and E. And actually, their reactions. Okay. So components of the reactions at A and E. And then force in BC and BD. Let's begin. This is what we need. So fixed supports also means you have parallel and perpendicular reactions. So draw that. I'm gonna assume direction. Okay, so let's assume this is to the left. Let's call that AV. I'm gonna assume this is upward. Okay, so that's A. Yeah, no, AV. This is AH. I'm gonna assume E is to the right. So this is your EH. I'm gonna assume this is also upward. So EV. Also, I need to know the forces in BD and BC, right? BC, BD. Four things. All right. Again, we're looking for reaction at support. One of the first things to do is moment at the other support. So you choose where you want to start, A or E. I want to solve first for A. So let's do summation of moment on the other support, which is E. Okay. So summation of moment E is 0. AV passes through E. EV passes through E, EH passes through E. So ignoring those three forces. Next, AH. Rotate about E. That's counterclockwise, so negative AH. Perpendicular distance is 2 meters, right? This is 2 also, so that's 2. Next, 12. Rotate, that's clockwise, so plus 12. Perpendicular distance is this length, which is equal to 2. So times 2. There's no other force. Wait, 0. Please solve. What's AH? Correct, it's 12. Very good. Positive 12. Correct, Rafaela and Emma. Nalangan and some points. Positive 12. Okay, that's one of our answers, right? Uh, Positive, therefore correct assumption, it is indeed to the left. Okay. Next. The only two other equilibrium equations we have for the entire structure is summation of forces, vertical and horizontal. Okay, so let's try vertical. Since I want to get AV. Okay, AV, EV positive, so as the word therefore positive. So AV plus EV. Then we have 12 downward. Negative 12 equals 0. There's nothing to solve for there, so we'll just have this as an equation number 1. Okay, since there's nothing to solve for. Again, you have 4 unknowns actually. 1, 2, 3, 4, and you only have 3 equilibrium equations. Therefore, at some point, we're going to use method of members. Okay, so let's see when. Well, we can also use summation of forces horizontal, right? Negative AH, positive EH. Let's move this. Let's pretend we did summation of forces horizontal first. Okay, again, to the left, negative AH. To the right, positive EH. There's no other horizontal force. Equate that to 0. And therefore, EH equals AH, which is 12. Positive, therefore correct assumption, it's to the right. So that's one other answer that we have. And then, when you move on to summation of forces vertical, there's nothing to solve. Okay, so now that we have that, next step is to use method of members, right? So as you can see, this is your 3-force member. So we can isolate them, since it's also connected to your joint A or support A. So member AB. Okay, let's draw. AH to the left. AV upward. And this is A. And then this is B. Okay, assume direction for B. I'm gonna assume BV is upward. And I'm gonna assume to the right. BH. And then don't forget your external force. Oops. This is 12 kilonewton. And then length. This is 2 and 2. 1, 2. Okay. Now that we have that, we can create new set of equilibrium equations. So let's start with moment again. Usually we start with that, right? Since I have AH, I want to get AD. We can do summation of moment at the other hinge, which is B. Summation of moment at B equals 0. AH passes through B, so ignoring that, AV rotate clockwise, therefore positive. Distance is 4. 12 counterclockwise. Distance 2. Okay, BVBH passes through B. They equate to 0. Please solve what's AV. Correct, it's positive. Correct, Francisco and Rafael. Pangalaman. Points to me. And then correct, Rafael Abuk. It's positive 6. Positive, correct assumption. Okay, our assumption upward. Next, now that I have AV, right? Sub in 1, right? You'll get EV. So sub here, 6 plus EV minus 12 equals 0. Therefore, EV equals 6 kilonewtons. Positive, therefore correct assumption, it's upward. Okay. Okay, now that we have all that, let's move this here. And so AV again is 6 plus EV minus 12. Okay, now I have all the components that we're looking for. The next thing we need to do is solve for internal forces of these two. Now how? Again, BD and BC are not 3-force members, right? So there's no point in isolating that right now. But since they're not 3-force members, they're 2-force members, meaning I can use method of joints or sections involving those two forces. Okay. Now, if you practice method of joints and sections, you'll know that the easier choice here would be method of sections, right? Because if I choose that, I can just do this, cut a plane in this area, and I can solve for BD and BC already. Okay. So method of sections. Right. Okay. We're gonna isolate that again. If you want, you can draw just straight lines. And let's make it smaller. And sorry. Okay. Next, draw your forces that cut through the members. So here again, I always just assume tension. Same thing here. So this is F BD. BC. Okay. And then now, again, you're going to use equilibrium equations to solve for the rest. So let's try summation of moment at D so that I don't have to deal with that diagonal force. Okay. EH passes through D, ignoring that. EV. Clockwise, therefore, positive EV, perpendicular distance is 2.5. Next, rotate. Counterclockwise, so negative FBC, perpendicular distance is 1.5. Wait to 0. EV6, please solve what's FBC. Correct? It's positive 10. Correct, Kenneth and Kurt. The Kenneth, Kurt. Positive 10. Positive, therefore correct assumption. It's tension. Next, how do I get FBD? And use the remaining equilibrium equation, which is summation of forces, vertical or horizontal. You can use either, right? You should get the same answer. Let's try doing horizontal. Okay. EH to the right, so positive. Now I need to get the horizontal component of FBD. So how do I do that? Again, I either need an angle or slope. I don't have angles here. I'm given dimensions. So let's solve for the slope. Okay, so this is 1.5, this is 2. Right? Again, this is the slope or the member that we need. So 1.5 and 2. Now, if you try multiplying those two values by 2, right? 2 times 2, 4. 1.5 times 2, that's 3. So this becomes 3, 4. And we all know the hypotenuse of a 3, 4 right triangle. That's 5. So you can do that just to make things easier. So it's a 3, 4, 5 right triangle for slope. Again, we're using summation of forces horizontal. So horizontal component is horizontal side, which is 3 over hypotenuse 5. So to the right, so plus FBD times 3 over. I'm gonna do that here as well. Again, this is 3, 4, 5. There's no other force, so equate to 0. Please solve what's FBD since EH is 12. Correct, Kurt. No. Correct, Matthew and Kurt. So negative 20. So that's 5 over 3. That's 20. So negative 20. That means incorrect assumption. It's 20 kilonewton. I assume tension, that's incorrect, so it's compression. Okay, there. And that is number 3. Any questions for number 3? Please answer in the chat. Okay, great. No questions. So I'm going to end the lecture there since we're almost time. So a few announcements before I let you go. Next meeting, Thursday, continuation of method of members. Then we're going to start a new topic, which is friction. I believe that's in your syllabus. Friction is the next topic, right? And then on Saturday, you'll have your quiz number 2. Coverage is analysis of structure. So method of joint, section, and members. Okay. And then for those who had an IP grade for module 1, I'm gonna upload an IP activity. Okay. Uh, that's gonna be at the bottom of the tabs. So let me show you. I haven't done it yet. It's gonna be somewhere here. It's below Panopto. Yeah. Your grade in BB is almost final. I just have to include the plus points. I'll do that later. Okay. So your final grade, you'll see tomorrow. So you'll know if you have to do IP or not. Okay. Again, I'll do it later. Check tomorrow to see what's your final grade. Again, for those who still had an IP, tomorrow, IP activities will be here at the bottom. Then you're just gonna answer that how many times as you want until you get a passing grade. Okay. This was explained in your orientation as well. Again, there's gonna be an exam here. You can open it whenever you want, when it's available, answer it how many times as you want until you get a high enough score so that your final grade is above 70% or 70% and above. Okay? So as you answer, your module grade will be updated real time. For those who have an IP grade, again, you're gonna look at, I believe, M1 for IP students. Okay, just look for the column with for IP students. Oh, really? Okay, I'm gonna, for those who still have issues with Coursera, I thought I already rechecked everything. So I'm gonna recheck again. Okay. If you want to make sure, you can send me first message telling me I still haven't updated your grade for Coursera. Okay. So that I won't miss it or I won't forget. Right? And then yeah, again, for those who have IP, look at the grade name that had parentheses for IP students. Okay. That grade will be updated every time you answer the IP exam. For those who had a grade of 3 and above, for those who did not get an IP grade, just ignore that grade column. Okay? Okay. I think that's it. Do you have any questions or concerns? Okay. So midterm assessment, you can upload as Word file. If you're not gonna format it in any way, Word file is fine. PDF if you added any decoration design on it so that your design is preserved if you do it as a PDF file. Again, if it's just plain text, Word is fine. You can just upload Word directly. I'm gonna explain your midterm assessment. Okay, so for your midterm assessment, this is supposed to be for week 5. Unfortunately, I was sick, so I wasn't able to explain. So this is found under week 5, okay? Because it's supposed to be for week 5. You'll see it here, week 5. Just answer this. Deadline is this Saturday, 11:59 p.m. Same day as your exam. So first, number 1, what have you learned so far in this class? Like what you really learned, not just don't include the entire syllabus unless you really understood the entire syllabus. You can also include there your favorite topics, the topics that you really understood, meaning you can teach it to someone else if needed. And also you can say or you can tell me what topics were a bit harder for you to understand. Okay. Number 2, what do you want to improve about the class? Do you think I'm talking too fast? Do you think the pacing is too fast? Is my mic having problems? Is it hard to understand me? Is it organized or not? Just let me know there. And 3 is the opposite, what we like to keep about the class. Do you like to keep bonus items? Do you like to keep the pacing? Do you like to keep how everything is presented in class? Just include it there. 4, what do you think about your overall performance in this class so far? Are you satisfied? Are you happy with your grades so far? Are you happy with the scores that you're getting? Are you disappointed? Do you think you can do better? Write it all there. And then number 5, suggestions. Anything else you want us to do in class? Anything else that you want to be done, or any games that you have in mind, any activities. And write it there. So that's your midterm assessment.
Ma'am?
Yes?
Ma'am, yung pong sa Coursera, kailan po mag-update yung grade doon?
I'll check again later if you've uploaded the correct files.
Okay po. Thank you po.
Welcome. Any other concerns? Okay. So if you want to make sure that I look at your grade, you can send me a course message because sometimes I miss certain columns or rows. Okay. No more questions? Okay. Again, lecture again on Thursday, quiz on Saturday. Since you don't have any more questions, you may go. Goodbye, class.
Thank you po, ma'am.
Thank you po, ma'am.